Hi, in this module, what we're going to look at is air conditioning. And we're going to use our simulator in order to model some air conditioning processes. And so in order for us to have clean and comfortable air, we have a number of processes that are going to happen. And we're going to look in this module at the summertime and wintertime operation of air conditioning systems. So this is our air conditioning plant, and we're going to make use of this in our sim lab this week. You can see it's pretty complicated. This is one of the more complicated systems that we have in our simulator. There's lots of data, there's lots of processes, and lots of pathways. And so in order to make sure that we don't get overwhelmed with the data that's on the page, I want to break out and talk a little bit about the theory and some of the components that you're going to see in this portion. Okay, so first of all, if we want to figure out what makes good indoor air, so we have a few things that we want to make sure we track. We're going to have a temperature, and generally our target is going to be in the 20 to 25 degrees Celsius range. That's where most people feel comfortable. We're going to worry about our humidity levels. So our relative humidity is probably going to be in the 40 to 60% range. Again, that's where most people feel comfortable indoors. We want to make sure that we maintain a reasonably high oxygen level in our air. And we'd like it to remove contaminants. So things like dust or odors or vapors that are in the air. We want to make sure that we have clean, fresh air. And so if we meet all these things, then great, we should hopefully have good indoor air conditions. So how do we go about that? Well, if we want to adjust our temperature, we're going to have to involve some heating and cooling processes. If we want to adjust our humidity, we're going to have to do some humidification or dehumidification. If we want to adjust our oxygen levels, well, we're going to need to make sure we're being aware of how much oxygen are we bringing in through fresh air exchange. And then finally, we want to make sure that we have a low level of contaminants in our air, and that's going to be through things like either fresh air exchange again, or else filtering. Okay, so we're going to take advantage of some of these things when we use our air conditioning system. So here's our air conditioning plant, and I got rid of a lot of the noise on our system. Okay, and so just to give you a brief overview of what our system looks like is we would consider this to be an air handling unit. Okay, and an air handling unit has a number of functions. One, it's going to be able to heat and cool. So we have a section where we can cool air. We have some steam heaters. Okay. We have some places where we can humidify. We have fresh air that's going to come in and then circulate it with a fan. And that air, as it goes through and gets conditioned, is then going to go to some sort of space which we want to heat or cool. Okay. And so this would be our typical configuration. Air comes in here from outside, gets conditioned through different pathways, and then makes its way to our space that we want to be comfortable for us. And back through ducts, then can either go and exhaust outside, or else we could recirculate around. Okay. So let's talk about a typical winter operation of this plant. We can see down here we have some inlet conditions that may be typical of wintertime. And we have a few different variables. So we have temperature T, which is -3 degrees. We have our R value, which is our relative humidity, and that's 30%. And we have our X value, which is the absolute humidity. And so our air is holding 0.94 kilograms of moisture. So we have some conditions, and ultimately what we want to do is increase our humidity and temperature, both are low, in order to try to get comfortable conditions in our accommodation area. Okay, so in order to do that in the wintertime, we're going to have to do a couple things. One thing that we're going to have to do is humidify. So we have this system down here, which we'll talk about in a little bit, which is going to be used to add humidity to our air. We also have a steam heater here in front of the humidifier. And we also have a steam heater after the humidifier. And we'll talk about those in just a moment. Okay. First thing that we'll talk about is humidification. Okay, and if we need to increase our humidity, the way that we got to do that is to add water vapor to our air. This system is used as a spray humidification system. And so we have a little spray section here, which is going to spray water into the airstream that passes through. And in general, how this system is going to work is we have a water supply that's going to fill a water reservoir tank, which can then be pumped and sprayed through a series of nozzles. In order to improve the ability for that spray to be absorbed into the air, we're going to make sure that we warm up this tank of water. So it's warm or hot water that's being sprayed in as opposed to cold water. So we also have a steam heater in order to warm up this tank. We spray this hopefully in a fine mist, and with lots of surface area, we should have lots of absorption of those droplets into the air and increase our humidity. We also had two heaters in our system. We had one heater that was in front of the humidifier, and then we had another one that was after. So we'll call this guy our preheater, and in this case, we're using steam in order to preheat the air. And why do we have to preheat the air? Well, first of all, cold air can't hold as much moisture as warm air. So when we do eventually warm it up, we'd be left with a fairly low amount of vapor in that air. So we need to preheat that air so it can hold more moisture when we go to humidify it. The other thing that we want to make sure that we do is we want to make sure that we don't pump below zero air through that humidifier. Otherwise, we risk freeze up, and we don't want that to happen in our humidifier. So we preheat the air, and we do quite a bit of heating in advance in order to allow that air to be able to absorb heat and absorb vapor in the humidification section. After it's been humidified, then we continue through, and then we have a post heater afterwards, which is going to be used to bring our temperature to our comfort conditions. So to summarize, in the wintertime, what we have is really three processes that we're going to typically go through. So intake air comes in cold and low humidity. We're going to preheat it so it can absorb that humidity. We're going to humidify it. And then we're going to finally heat it again in order to meet our comfort conditions. Okay. Let's take a look at the summer configuration. It's a little different. Okay. So first thing that's happened in the summertime is we've adjusted the airflow so that it is not going through the heating sections, but now instead we're going to go through this upper section. So we can see that our conditions have changed. So our starting conditions now, we have a little warmer temperature, 30 degrees that we're starting, and it's quite a bit more humid, so 90% humidity. So has a lot more moisture. Before we were around 0.9, now we've got 24. So that air is carrying a huge amount more moisture with it. So we have hot, humid air that's coming in, typical of a hot, humid summer day in our area. And so if we follow through our pathway and sort of our decision making, what we need to do in order to get to our comfort conditions is we're going to have to decrease the humidity and decrease the temperature. So let's just see what processes we're going to use to do that. So we have fewer processes this time. We only have 2 of them. We have a refrigeration plant, so typical of what we may see. We have our evaporator, we have our compressor, we have our condenser, and our expansion device. So a typical refrigeration system that we can use to cool the air. And then we also have that final heater that's available at the end. So we have a second device, and we'll see where we use that. It may surprise you. Let's talk about dehumidification first, because that's going to be the most important thing, or the most difficult thing for us to do. So adding humidity is easy. We saw that. We just spray in some water, and if it's warm enough and that air can receive it, then the humidity will increase. So that's a pretty easy process. Dehumidification is hard. How do we remove humidity from hot, humid air? Well, nature already does this, and it can show us what this process is. And when we talk about do is the process of removing humidity from air. And when we have hot, humid air that cools at night, we form dew. And dew is just humidity that condenses out. And what's left is some air that holds less moisture. So dew is going to be the process, or the condensation through dew is how we're going to dehumidify our air. But it has some disadvantages. So one is that in order for dew to form, we really do have to cool it quite a bit, more so than comfort conditions. The other issue that we have is that when we do bring air down to the dew point, the relative humidity goes up to 100%. So we're left with air with a high relative humidity and a low temperature in order to get rid of that humidity through dew. But we don't have much more of a choice. That's kind of what we have to do if we're going to remove humidity. So we do both of these things with our refrigeration plant. So by cooling the air as it moves through, we can also cool it to the point where we form dew. And we create some condensation on the surface of that evaporator. So we cool the air there, and we also try to remove the moisture. But we also are overcooling it, because we have to prioritize getting rid of the humidity in this step, because that's the only chance that we can bring the humidity down to comfort conditions. And in order to remove enough humidity, we're probably going to have to cool this air quite a bit. We may cool it down to 5 or 10 degrees in order to try to meet a comfort condition at the outlet. So we're going to overcool it likely in this case, especially if we have very humid air. We have to prioritize getting the humidity right in this step. Don't forget, we still have that heater after the fact that we could adjust the temperature afterwards. So our post heater might come into play. And it's sort of counterintuitive in the summertime that we may rely on heating, but in order for us to get our air back to comfort conditions, we may need to do that. And so we would do that after the fact, after we cooled and dehumidified the air. We'd warm it back up in order to make it comfortable. So as a summary, our summer conditions, we bring in air, we cool it and dehumidify it, and then we use heating afterwards to make sure that we have met our comfort conditions. One last point, when we have a system, we want to make sure that we have good air quality, and that may involve filtration, and we would likely have some filters built into our system. But Another one that's really important is making sure we have fresh air and we are introducing new fresh air on an ongoing basis. It brings high oxygen levels and lower contaminants the more fresh air we can bring into a system. But we don't want to necessarily run on 100% fresh air. Fresh air that's coming in from ambient conditions is as far away from our comfort conditions as we could possibly be. And so that means that we're going to have to expend a lot of energy in order to bring fresh air to comfort conditions. And so in order to minimize or reduce our energy consumption, we tend to recirculate some air. And so we have some recirculation pathways that we can use in order to recirculate some of the already treated air that can then blend in and move through. And that's already pretty close to our comfort conditions. So in theory, we shouldn't have to expend as much energy in order to restore it back to its comfort conditions. It's already probably pretty close to begin with. And so we typically have a recirculation pathway in some of these systems in order to try to blend the right mix of fresh and recycled air inside of a system. Okay, so I think we've got enough theory in order to be able to complete our exercise this week in the simulator, and we'll operate and look at some data on our air conditioning systems. All right.